Hello, welcome to the first lecture here in the webinar series, and I'm going to talk about recognizing spring annual disorders. The purpose of this presentation is to share with you some of the dead plants that I love photographing, because I typically like to go into greenhouses and take shots of problem plants. And so by showing you these plants that have had problems, it's going to help you recognize what these problems are, help you then diagnose what a problem is if it occurs in your greenhouse, and then also, in some cases, take preventative measures to avoid some of these situations. So let's get started of looking at some of my great dead plant photographs that I have. Now, the plants we're going to focus on are primarily vegetative annuals, and we're looking at plants from Alternanthera over through Terrenia. So basically 10 different plants we're going to focus on with this presentation. So let's start with Alternanthera. So the main situation or the problem that I want to focus on is short day situation or flowering that occurs under short days. So what do I mean by that? Here's the case in the photograph. If you look here, the plant on the left had long days. It had night interruption. And it is nice and full. As you can see, it has a lot of leaves and everything going on. A nice looking plant. In comparison, look at the plant on the right. Those were grown under natural short day conditions of wintertime. And what do you see? It's thinner. There's less vegetative growth. Flowering has occurred on the plant on the right. And so those plants are smaller. There's not as much vegetative growth. And at the end of each of those shoots, there's a small clover-like flower that has been produced. And so I grew these plants further out, and it is very difficult to get the plant on the right to jumpstart and then become full. So you need to provide long days with a night interruption to Alternanthera to avoid this. And so to do that, here's a case of a grower in North Carolina. They've strung some lights. They have the black cloth there you can see in the background, and they pull that every night. And this photograph was taken when poinsettias were being grown. So, of course, it was important to pull that black cloth so you can still get your poinsettias to bloom because they need long nights, whereas these vegetative annuals, they needed long days. So that's a simple way of doing it. A 10 p.m. to 2 a.m. Night interruption with the lights will take care of that situation on Alternanthera. And it's the same situation for all the cultivars that are out there in the market, so you can use that to help prevent the problem from occurring. With Bacopa, what we see is plants that do not have many flowers. You can see a few flowers in the lower part of the plants there on the bench. But primarily it's green foliage. What's happening here, and that is Bacopa does not like to be drought stressed. So this whole crop here was being grown on the dry side. The flowers die. And so if you grow them dry, you're going to run into problems with this plant. So you need to avoid that. There's a lot of growth there. Probably a plant growth regulator would have helped to moderate some of that growth also to help avoid that problem. And here's a little closer shot of the same plants. Now I want to point out that in the lower right you see a number 2-24 in e-GRO. That means that we covered this particular problem in one of our e-GRO alert newsletters. So you can go back to the e-GRO website, e-GRO.org. That's e-gro.org. And then under the alerts, just go on down to 2.24, and then you can see the actual full-blown article that we did on this particular problem. So, drought stress and Bacopa don't go along very well together, so you need to avoid stressing them to keep the flowers on the plant. The next plant we're going to look at is begonia, and it's dragonwing. Now, it's really not a vegetative annual, and so there's a number of problems that we want to look at that we have seen. Drought stress, pH problems both low and high, and then INSV. So when you're looking at drought stress for this plant, some people might say it's unusual. I talk about it because the plant is fairly drought tolerant. And you can see the plant in the upper right has nice green foliage. It's growing. But if you drought stress it, severely drought stress it, I think you have root loss, and then those plants have a hard time recovering, if they ever do recover. And what you see there is that primary plant. In the photograph, you see the leaf curl, you see more reddening of the leaves, and you see lack of growth. And typically what then happens is, if it's only a few that problem occurred on, then those plants are always stalled, and probably you'll end up getting more of a root rot problem because you're trying to irrigate for the ones that need the water. And so it just keeps on snowballing on you as far as being a problem. So don't overly drought stress the type of plant like dragonwing begonia. Now, another situation we've run into, and it's more of a problem on the southeast because it hasn't been reported that much in areas that have more alkalinity in the irrigation water, is a problem with low pH. And you can see the plant on the left, you see the marginal burn, the discoloration, and then a close-up of the leaf on the right. The pock marking is kind of yellowish, bronzing, and then turned to brown. Those are all symptoms of the pH being too low in that plant. Here's another close-up that we've taken on photographs, so you can see it's a little more of a blackish discoloration. Well, when we tested the substrate, the pH was 5.1, and that's a good indication that we're having a low pH problem. Basically, you're seeing an accumulation of iron and manganese, and so it's a toxicity that's causing that necrotic situation occurring on the plant. To do a further follow-up to make sure that we confirm the diagnosis, then we did a tissue sample of a good plant versus one with symptoms. And you can see there highlighted with iron and manganese that in the symptomatic plant, iron was at least 2 times higher and manganese was 3 times higher. So you're seeing that accumulation, those micronutrients in that tissue, and that's what's causing the problem. So we confirmed it both from a pH test, that gives a good indication, and then the real test here is doing the tissue confirms the diagnosis. And we covered that a little more in detail in 2.23 if you want to look at this problem further on your own. Now, I'm not going to go into corrective procedures, but we do have a handout on the e-GRO website. Last year, in 2014, I ran 3-05 as corrective procedures. It's been updated, and it will come out as 4.02. And the addition to 4.02 is a number of pages that include optimal pH ranges for many of these crops. So I think there's about 10 pages of tables. So it's a nice improvement from what we had last year. So it's a great resource to use if you have problems of low pH or high pH for diagnosing and correcting those type of situations. So I'd encourage you to download that if that's what you actually want. Now, on dragonwing begonias, we also sometimes see, but it's not very often, interveinal chlorosis, so yellowing between the veins of the upper foliage. And that's due to a high substrate pH. That high pH ties up the iron, and then without the iron, you see those deficiency symptoms occurring. It doesn't occur that often, but it has been noted on a number of occasions that when I'm looking at plants in a greenhouse, and just want to make you aware that that situation is there. So to avoid most of these pH problems, really, when you're looking at dragonwings, I would recommend using the range of 5.6 to 6.3 as the pH range you should target for growing this plant to avoid problems. Now, one other problem with dragonwings is thrips vector disease, a virus called INSV, impatient necrotic spot virus. Symptoms can be like what you're seeing there on the left, which is a mottling of the foliage, or more brown discoloration can also occur. So there's a lot of variation of symptomology that's there. But just want to make you aware that this disease has a potential to affect this plant and any of the other begonias also. But this has been noted a few occasions as being a problem with dragonwings begonias. Now let's shift to coleus. Coleus had a big problem a few years ago with downy mildew. I thought it was going to end that plant as being a major one that you would still plant in your garden. But we actually had that spike of problems a few years ago, and now it's been much less. I did see one instance last year, so I want to talk about downy mildew. I want to talk about western flower thrips, INSV, and then finally foliar nematodes. So if you're growing coleus and you all of a sudden start noticing some of the lower foliage is yellowing, you might have dried it out, you might have low nitrogen, but you need, especially if it starts curling and it's kind of discolored, you need to look at those leaves And you need to look, the leaf might be yellow on the top, like the leaf on the right. But if you turn the leaf over and you see a fuzzy growth on that plant, that is a sign that you have downy mildew. And like I said, only one instance happened last year in 2004, but it pops up. So, a preventive spray program is going to be the answer to avoid that disease. It's not been as severe as I thought it would be when it first broke out a few years ago. It's actually been, in most cases, managed quite well by growers. The other situation here is western flower thrips. These are actually plants from our greenhouse that we were growing in an experiment. And you look at the plant, the photo on the left, and you see that there's not really much damage whatsoever, no streaking, nothing really going on. So you kind of have a feeling that, well, that plant's doing pretty well. That same leaf turned over, you can see this white scarring on the bottom side. And so this is the result of western flower thrips feeding. The take-home message here is that on these coleus plants, when you're scouting for the presence of western flower thrips, you can't go by the top foliage for symptoms. You're going to have to turn the leaves over and look, and that's in fact where they were in doing the damage. So just wanted to point out the placement of where the damage is and where you need to look for your scouting purposes. Now, it's important to control western flower thrips because they can be the vector. If you have the disease, INSV, in the greenhouse, they'll spread it. So you're seeing here very advanced symptomology. You see the ring spot that's necrotic on the left, and you also see more blackening ring spots on the plant on the right. Now, it can be just a modeling symptom that might occur on some of these other colors of coleus. So you're going to just have to be aware of looking for an odd spotting, then have it tested by a diagnostic lab or get your own ELISA test kits to confirm that is in fact the problem. But INSV and tomato spotted wilt can both be a problem with coleus, and you need to be on the lookout for that. Now here's an oddball. We ran into this last year at one grower, and this grower held back some stock plants. And so what do we see there? We see necrotic areas, but look how angular that is. It's very blocky. Well, anytime you start seeing that blocky tissue occurring, you really need to start thinking about two possible causes. One, which is the most common, would be a bacterial infection, a xanthomonas, Pseudomonas type of infection that would occur on plants, because bacterial infection like that has a hard time jumping over the veins. But that difficulty of jumping over those subveins from one section to the other also occurs with a foliar nematode. And that's what we have here. By slicing that leaf right there by that lesion and then putting it in water, you'll see them stream out of there with a good microscope. It looks like little fishing worms in the water, with the foliar nematodes being actually inside the leaf tissue. Eradication is darn near impossible, and so crop rotation, getting new stock in, is the best answer for overcoming that particular problem with the plant. For dahlia, I want to touch briefly again on stalled plant growth. We've talked about this on a number of e-GRO alerts, 2.05 1 year, but if you see your dahlias, they're prematurely blooming, they don't have size, start digging in the soil and looking for the tuber. Now these were cutting dahlias, so they didn't come in with a tuber. If a tuber starts happening, you know that you have not provided long enough days. You need to either have a nighttime interruption, or for some of the propagators, they recommend that you have a day extension. So you start the lights before nightfall begins and run it like till 10 p.m. at night. And those long days will help avoid the tuberization occurring on that plant. And so you can see here the plant on the left. You can see how the leaf shape changed from multiple lobed leaves to one oblong leaf. Those are reproductive type leaves that lead up to flowering. And so the plant on the left was taken out of the pot, the roots were washed, and you can clearly see the tubers have formed, and that plant stalls. And it is very difficult to restart that plant being vegetative if you get those tubers forming on that plant. The same thing goes for nonstop begonias. It's a very hard plant to get jump started again. And so you need to avoid that, and how you do that is either have the nighttime interruption or day extension, and you have to run that through about March 21st. And the same thing goes for like Alternanthera. You need to light those until that point to keep them from flowering. On Ipomoea, there's been some cases of distortion by either edema or scarring, so I want to look at that. So I've gotten some calls in the past when you see these weird bumpy growth coming either on the bottom of the leaf, that's the plant on the left, or the top of the leaf. And then over time, because there is sap that's in there, it might leak out. You can get some sooty mold and then some dry down of some of those nodules that are coming out. So this is edema. Intumescence is also called. There's a great article that's been run in the last year out of the Kansas State group that you might want to read about this in more detail. But edema, while it doesn't look that great, usually it only happens at one point at a time on a few leaves, and then the new foliage covers it up. But people are quite concerned when they see it for the first time on their Ipomoea plant. When you look at distortion, and these are unfortunately out of our greenhouses on campus at NC State, that we are fighting western flower thrips at some point. And I want to point out that you have more of the blackie type that's on the left, and you see the typical white scarring that occurs when you have thrips problems, while the chartreuse variety seems to be a lot more tasty or preferred to western flower thrips. And so look at those leaves. They're distorted, there's holes in them, and the reason for that is that a western flower thrips likes to be in the growing tip where it's tight. And so when it's feeding on those small leaf tissues, it doesn't take much damage where they come in, they rip the tissue, and then they drink the juice. And so therefore, when that leaf expands, you'll see those resulting holes on that plant leaf, or the leaves growing very oddly. And so that's the result of western flower thrips feeding. So that's something to be aware of, and you'll have to control that insect well before it gets to that degree of damage. On petunia, there's a number of problems here to go over. The first one, and the most common one, is the upper foliage starts developing an interveinal chlorosis. Then it gets more pronounced at the moderate stage, and then it can bleach out to a total yellowing or white at advanced stage. And this is due to the substrate pH being too high and irons tied up. So you need to grow petunias at a lower pH. And the pH range really that we're looking at, the refined range, probably recommend between 5.4 and 6.0. And you should avoid the problem of having the pH too high, and you get that interveinal chlorosis happening on the plant. Now, that range included avoiding growing the plants at too low of a pH. And here's an experiment we ran by varying the amount of lime we put in the mix, and the corresponding pH values are listed there from 3.3, 4.8 to 5.1. And then consequently on the last line, the dry weight reduction, you can see that from a pH 5.1, if we grew them slightly more acidic at 4.8, the plants were 29% smaller, and compared to the 5.1 plant, when we grew it at 3.3, they were almost 60% smaller. So not all damage to a plant when the pH is too low is a leaf damage. It can be stunted growth that can occur. And I want you to be aware of that, because you might not notice that the overall crop is not growing as well if you're running it on too low of a pH. So the pH, getting it up closer to 5.4, 5.5 would be recommended to overcome this situation. White mold can also happen. It's not very often that it occurs, but we have seen it more in North Carolina during the months of March. Usually, if you got a big canopy with the plants and you get an overcast, high humidity week, we'll see some outbreaks occurring. Typically, you'll notice first the stem wilts, and after the stem wilts, or if you look in there, you might see that white cottony growth that's in there. Give it a few more days, the stem will go totally brown, necrotic, like you see in the upper right. And then if you break that stem up, you'll see the sclerotia that form. They're small black beads like that. And in this case here, this one will form on the interior of the stem, but very likely on that plant that is there on the left, that's a big enough cottony mass developing. You probably would see a sclerotia occur on the outside of that stem there. So inside or outside, this can occur. Now, the challenge with that sclerotia is it can survive for a number of years in the soil, so you need to take the plant out of the greenhouse. At this point, you can't really control it with a chemical spray. You could trim it back and be okay, but you need to get out those long-term survival sclerotia so you don't have the problem again next year in your greenhouse, or give that problem to someone in the landscape where they would have the problem for a number of years. A number of years we've been talking about problems we're seeing specifically with yellow cultivars of petunias and propagation, that they might develop roots, but the top growth is either yellow or necrotic, as you see there. Roberto Lopez and crew at Purdue wrote an e-GRO Alert 210 that covered this in great detail, so I'd highly recommend that you download that. But what they found is that the plants did root well, but the top growth was problematic, and that they did tissue samples and found that under mist that there was a big decline, especially in iron, manganese, and calcium under that mist, and it took fertilization to help bring that level back up. And so basically they found that by adding that supplemental fertilizer, they can avoid the problem. And they recommended fertilizing petunias under mist by day 4 to 6 and using about 60 part per million of a balanced feed that has boron, calcium, and iron and manganese. Or in the case of the experiment they were running, they also did some slow release fertilizer being added that also seemed to help. So read that 210 for more details, especially if you're having problems with yellowing of the upper foliage of your some of the yellow cultivars of petunia. Last year there was a big problem that occurred with tobacco mosaic virus. You see the mottling, the clear distinctive mottling on the foliage on the left, and also the similar symptomology of mottling occurring on the flower on the right. The problem was with one main propagator, but I can tell you from other years that other propagators have had problems too. So it's just not a situation of a problem of one operation. Now, I can also say that the propagators, that this is a disease they're really, really worried about, and they have a lot of protocols in place. So it's unfortunate that it happened last year, but at least it is something they have a preventative program for. Scaevola iron deficiency is the biggest issue. You see that interveinal chlorosis, that yellowing between the veins of the upper foliage, and you can see it closer up here. One thing to be aware of, that Scaevola is one of those Australian plants that came in, and most of the Australian natives natively were selected for soils that were low in phosphorus. And so if you in the greenhouse supply high levels of phosphorus, you can tie up some of that iron. And so the recommendation is trying to avoid excessive phosphorus, and so don't be growing this plant with a lot of 20-10-20, because that high phosphorus level will also aggravate the situation of tying up that iron. I mean, high pH situations will also, but that I think you got to look at both of those factors to try to avoid this situation with your plant. So ideally, targeting a pH between about 5.8 and 6, or a little broader, 5.6 to 6.2, because Scaevola is pretty tolerant, but that phosphorus level needs to be pretty low on that plant. Every year I usually notice that some people have strobilanthes that have this flower bud on the tip, and that is also due to the fact that they produce flowers during winter, during short days. To avoid that, you have to light them with a night interruption, and then you will keep them vegetative. And you can see those leaves. Look at those leaves below the flower, how they're a little more oblong. It's not the typical strobilanthes leaves that are nice, long, and wide that you see on the plant. So you know the plant is reproductive, it's flowering. And the problem is, many times when you get to this stage, the plant growth, the vegetative growth, will stall. And so you will not get a full, nice looking plant under these conditions. So you need to light those plants with long days through March 21st to avoid this problem. As far as Torrenia, brown stems is the biggest issue to point out. And what I'm talking about here is that instead of having nice green stems, as you can see on some of the tissue on the left, it's starting to brown. And that's just not age. That is an INSV showing some signs. You sometimes will also get the mottling occurring, and so this is a situation where you want to try to avoid it. It's of course spread by western flower thrips, and we highlighted that in 204. In comparison to that is just lower leaf reddening. So you don't see the mottling occurring. You don't see the brown scarring on the stems. In many cases, when the scarring gets really bad, you'll see a canker go all the way around, and you'll see a stem die with INSV. When you're not fertilizing enough, you're just going to see an overall pale coloration or reddening occurring with the plants. So just to try to differentiate between a major disease problem versus the need to adding some more fertilization to the plant to avoid the problem. So hopefully by showing you what these problems are, you're aware of them, you can identify them, and in some cases do some preventive practices to avoid them actually occurring in your greenhouse. So a lot of this information was also updated in many of those e-GRO alerts. So you can go back and look for more details if you want to download that information there. So with that, I'll open it up for questions, and I want to thank you for watching this presentation.